Okay, let's dive right into this explainer. Today, we're tackling a super specific but honestly universally relatable developer challenge in Haskell. We're talking about dealing with custom document layouts, external files, and figuring out how to package all that up without completely losing your mind or driving your users crazy. If you've ever built a command line tool that needs to spit out a beautifully polished document, you already know the actual app logic. That's usually the easy part. The real nightmare kicks in when you try to bundle the whole shebang together so someone else can actually install and run it without needing a 15-step instruction manual. So the author of our source material, Ang, started off with this exact frustration. It's a wall almost every developer hits at some point, realizing the default tools just aren't going to handle complex real-world requirements. Specifically, Ang found that when dealing with Chinese text and highly specific layout configurations, the default Typst template simply falls short. It just doesn't cut it. You literally can't rely on the out-of-the-box settings if you want the final document to look right and render those characters accurately. You have to step out of the default lane and build something entirely custom.
And this brilliantly illustrates the core dilemma we're exploring today. How do you guarantee your custom layout works everywhere? Like, how do we ensure these highly customized templates render perfectly on any user's machine without making the app a total nightmare to configure? It's the classic battle of granular customization versus broad convenience. You desperately want the precision of a bespoke layout, but you also really need the ease of a simple click-and-run distribution.
Let's start with the root of the issue. Section 1, the PDF layout problem.
The context here is that the author actually had a really solid early victory. They successfully managed to generate PDFs by mapping parsed tokens directly to Pandoc's abstract syntax tree, or AST for short, and running it through Typst. That is a fantastic technical foundation, but they almost immediately hit a wall. To get the output they actually needed, especially for those complex character sets we just talked about, they required a highly customized Typst template to bridge the gap between Pandoc's raw, structured output and the final polished PDF. Because without that custom template, the AST is really just raw data sitting there without any proper visual styling.
Which leads us perfectly into Section 2, baking the template in. After days of tweaking and experimenting, the solution the author settled on wasn't to carefully manage some loose, fragile folder of external configuration files. Instead, they used the embedded template approach. Think of this literally like baking ingredients into a cake. Once it's in the oven, that template is permanently part of the final executable binary product. You aren't shipping a program over here and a template file way over there. You're shipping one single self-contained unit. The massive relief with this is that once the compilation is done, you never have to worry about a user accidentally deleting the template file or the program looking in the completely wrong directory path. It is entirely self-sufficient.
Now, what's really fascinating here is how straightforward the spell to bake this in actually is, using just a few lines of Haskell. It's an elegant three-step process. Step 1, you just add the file-embed library to your dependencies in your package.yaml file. Step 2, you activate the template-haskell language extension, which is incredibly powerful, by the way, because it allows for compile-time meta-programming. And finally, Step 3, you use the embed file function. This literally binds your external Typst template directly to a byte string in your code. Just like that, the file is read during the build process and physically embedded right into the binary before it even finishes compiling.
As the author noted during this process, the immediate goal was just getting a working prototype functional before moving on to refactoring. And honestly, we can all relate to this, right? When you're deep in the weeds trying to get a complex integration to work, like marrying Haskell, Pandoc, and Typst, you have to prioritize ruthlessly. Perfect validation, spotless architecture, yeah, that can wait for the refactoring phase. The absolute top priority is proving the core concept works. You just need to see that first PDF actually render correctly on your screen. This brings us to a brilliant little side quest, Section 3, a functional error handling trick.
So even while just prototyping, the author found the really neat shortcut. Normally in Haskell, dealing with operations that might fail involves writing out a full case statement. You have to explicitly tell the program what to do if it succeeds and what to do if it fails, which can take up several clunky lines of code. But instead of writing all that out, they used a very slick trick with the either function. It's literally just one line, let template equals either error, ID, template either. It's incredibly concise once you understand the underlying pattern.
The crucial takeaway here is how cleanly this one-liner splits the logic. The either function handles two distinct possibilities. If the result is a left value, meaning an error occurred during compilation, it uses the built-in error function to print a message and immediately terminate the program. It intentionally fails fast, which is exactly what you want when prototyping. But if it's a right value, meaning success, it uses the identity function, or ID. This just smoothly passes the success value on exactly as it is. It's a wonderfully elegant way to handle state and potential failure without clogging up your file with boilerplate code.
But, as we know, every technical solution has a cost. Let's look at Section 4, Friction versus Distribution.
This table right here presents the ultimate developer's dilemma. On one hand, embedding the template creates an excellent distribution experience, a single, robust binary that just works for the end user. But the developer experience? It's much, much slower. Because the template is baked directly into the Haskell code, you have to wait for the entire app to recompile every single time you tweak a margin or change a font size. On the other hand, using external files is the exact opposite. Development is way faster because layout changes update instantly upon saving. But distribution? Absolute nightmare. You have to figure out how to reliably package and locate those template files alongside the console app. It creates massive friction for the user.
Luckily, to ease that heavy development friction of the embedded approach, the author notes a very practical workaround. You don't actually have to suffer through the painful Haskell recompilation loop just to check your margins. You can simply grab the raw, generated Typst output from your Haskell app and then compile it manually using the standalone Typst command line interface. This effectively bypasses the Haskell build process entirely, allowing you to test visual changes instantly. It saves an immense amount of time and sanity while you're actively tweaking the design.
Ultimately, making the final choice came down to long-term reliability over short-term comfort. As the author states, keeping everything in a single binary is the most robust way to ensure the app just works out of the box. They hadn't quite figured out a perfectly clean way to distribute loose template files. So, ensuring the application works seamlessly for the end user out in the wild massively outweighed the slight annoyance during the development process. As we wrap up this explainer, I want to leave you with a thought regarding your own projects. When push comes to shove, which of these priorities usually wins out for you? Do you optimize for your own speed and convenience during development? Or do you take on that extra compile time penalty to ensure a flawless, zero configuration experience for the person actually using your software? It's a fascinating balance, and one that truly defines the craftsmanship of building tools for others. Thanks for joining me, and I'll catch you in the next one.